Hello, grade 10s. Today's topic on the weather is how the oceans affect the weather that we get. We're going to take a look at global ocean currents. So just like warm and cold air are always moving from the poles and the equator, so we get warm and cold water moving as well. Most of the water that we're going to find on the Earth is near the equator, at the oceans. And that's where the sun's light is the most concentrated. And that means that the water near the equator is going to be a lot warmer than the water is at the poles. And because the water, just like with air, will move from warm to cold, that will actually transport heat around the planet. So water, as it moves around in the ocean, actually forms rivers right through under the ocean surface. So we actually have rivers moving around within our ocean. We call these rivers ocean currents, and they have a really big effect on the world's climate and weather. In this map, you can see some of the different ocean currents that are really important to weather on the planet. If we are to write a final exam, these ocean currents some of them will be asked for you to label on a map. So I want you to pay attention to some of them, especially some of the ones that surround Canada. Take a look off the west coast of Canada. There's a very warm current, red means warm currents, that travels up from California, up past Vancouver, and curls around past Alaska. This brings warmer water up from the south, up past Vancouver, and is responsible for some of Vancouver's nice warm climate. On the opposite side of the country, in Newfoundland and Labrador, we see that we have much colder climates, even though we're at the same latitude. This is because cold water from the Labrador current travels south, and this carries colder air masses above it. So not only is the water warm, but it warms the air mass above it. Another really important current that affects most of the weather on our northern hemisphere is the Gulf Stream. It's named such because it brings warm water up from the Gulf of Mexico, up past the United States, and then it goes across the Atlantic Ocean to warm up this part of Europe. And it's part of the reason why in England, where we're very similar again in latitude, they don't have the same kind of cold winters that we have, and their ports remain ice-free all year long. That Gulf Stream starts a really big rotation of water right here, and that rotation of water has a major impact on the overall temperature of the planet. So countries such as Norway and Iceland, because they're so much further north than most of our cities in Canada, you might expect that they would have very cold winters. But because they're beside a warm current, because the Gulf Stream flows past them, they are actually very warm in the wintertime. And it's the same reason that the west coast of Canada has mild winters, because a warm current flows past it. It stays very warm in the wintertime. So we could see that warm water from the poles is going to travel, warm water from the equator is going to travel north to the poles in the northern hemisphere and south in the southern hemisphere. And cold water is going to travel southwards. Now this is part of a really important thing, because not only are these rivers flowing north and south, but there's also a difference in the amount of salt that they can hold. Warm water can dissolve a lot more salt than cold water can. So that's one important thing for us to remember, because the oceans are salty. The ocean will actually be saltier when it's warm than when it's cold. Also, cold water we have a density difference between them. I'm going to link this to another video to help explain that. So there's a word for it called thermohaline, which talks about temperature, which is the thermal part, and haline, which talks about salt. So this warm water, as it travels north, will eventually cool off and deposit some of the salt. We're going to get very cold, dense water that's going to sink, and it's going to travel back down through the Alaska current back to the Gulf Stream, and we're going to get this continual convection current going around the oceans. So there's actually a few things that are causing this water to move. One is the convection. Warm air, just like warm water, will rise and cold will sink. And weather and water always moves from warm to cold. Another thing that's causing the ocean to move is the fact that prevailing winds blow across the ocean. Remember, at our latitude, the winds always come from the west. And over time, that actually starts to get the water moving. Another thing that gets the water moving is the fact that it's not fixed hard in place to the earth. So as the earth rotates, we start to set up convection current. We start not convection, but currents because of the motion of the earth underneath. Then as the water gets moved by the warm and the cold and the wind and the fact that the earth is trying to move underneath it, it's going to hit large land masses of continents, and that's going to cause it to bend from its intended path. We know that warm water will be saltier than cold water will, so that's going to affect how the water moves. And finally, the Coriolis effect is going to affect how water moves. So we've got all these different forces in play that are making the water in our oceans into a series of fast-moving rivers. And what's really interesting is they're all interconnected. This picture shows how all the oceans on the planet are interconnected and that the water is moving from warm to cold, warm to cold. I'm really interested, and we're going to talk a lot more about this Gulf Stream here. As this warm water from the Gulf Stream moves up past Europe, cools off, sinks down by Greenland, and falls down until it's cold again as it comes back around, we set up a really interesting weather pattern. And it carries lots of warm, moist air above it to keep this area of Europe, and in fact even this part of Greenland, quite warm. And once it's dropped all that moisture, then it's bringing cold, dry air down this way, down to the deep ocean, and where the sun warms it again. Now, this particular current is an interesting one because at the end of the last ice age, there was a great big lake that covered North America. You might remember from geography, Lake Agassiz. And when that lake melted at the end of the ice age and the ice dam at the St. Lawrence Seaway broke, it released a lot of fresh water into the ocean and actually stopped the Gulf Stream. Now, when it stopped the Gulf Stream, that actually stopped the convection currents that brought up the warm, moist air to North America and caused another ice age to start to happen. So we had another period of rapid global cooling. Now, here's what's really interesting. We're going, well, that's okay because we don't have any massive glaciers in North America anymore that could melt it. Or do we? Greenland is covered almost entirely by a sheet of ice, and we know that that ice is thinning. Ice sitting on top of land is fresh water. Fresh water is less dense than salt water, and if it were to all enter the oceans quickly, it could possibly stop the Gulf Stream. So I'm hoping to find you a couple of videos to help you explain that to you a little more interesting. So when we think about countries like Norway, their nice, warm, relatively, for our northern hemisphere anyway, winters are caused by the Gulf Stream bringing up that warm water, which of course carries warm air above it. If you were to look down at the coast of Peru on the west side of South America, you'll notice that there is a cool ocean current, and cold air can't carry as much moisture as warm air can. And so that actually causes this part of Peru and Argentina to be very dry and desert-like. So we can actually get tropical and desert areas because of the type of ocean currents. Even in Canada, that warm ocean current, the Alaska current that travels up beside BC, brings in so much precipitation with it that Vancouver is known to be very rainy and actually is considered to be in a temperate rainforest. Now, it's not a tropical rainforest, it's a temperate rainforest. But there's so much rain that is associated with that warm current that they get nice warm winters and lots of rainy weather. So obviously, our ocean currents are having major impacts on the Earth itself. I want you guys to complete task 4, where you will label the main ocean currents around the planet on a map. I will post today or tomorrow a couple of other videos to help explain in a little more detail how these ocean currents work and also how they affect the weather.